guys be quiet and pay attention. Let's keep learning stuff. So now I'm going to ask you guys a few more questions on this one. You guys can help me, right? I do, we do, you do, right? So this is the we do part. We're going to do this together. I want to pick one of those equations and solve for a variable. So what do you guys think? Raise your hand if you have an idea. What do we do? Well, I'll get you started. You're either going to pick this equation and solve for a variable or this equation and solve for a variable. Oh, very good choice. Yeah, so let's do this top one and solve for y. So if I say negative 3x plus y equals 11, to solve for y, I just add 3x to both sides, don't I? So when I add x to 3, or when I add 3x, I can't talk. When I add 3x to both sides, these will cancel and I get y is equal to 3x, and that's a positive 11, right? So now here's the trick. I'm going to take this equation right here, and I'm going to rewrite it right underneath. I'm going to say 2x. Oh, negative 2x. I'm going to say negative 2x plus y equals 1. Now, I'm going to give you guys a second to write that down, and I think maybe you need a second to process that. It's the, yeah, hold on a second. It's the exact same equation, except I haven't plugged in y yet. But I happen to know that y can equal this stuff. Yeah? Doesn't y equals this stuff? So what do you think I can do? Yeah. Now, before I move any further, look at this line right here. See, the problem is, if I go to solve for x or y on this, I'm still going to have the other variable. In other words, I solved for y here, but I still had x over here. And if I were to do a similar thing over here, I'm still going to have x and y. I move stuff to one side, move stuff to the other side. But when I substitute, what do you notice here with regards to the variables? Yeah, there's only x. That's not an accident. Now, if I have x and a bunch of numbers, I can make it look like x equals some stuff. But if I have two variables, no matter how I move it around, there's going to be an x on one side, y on another side. They're on the both, you know, I can't really solve it. But when I have just x's and numbers, or in some cases, just y's and some numbers, I can make it look like x equals some stuff, or I can make it look like y equals some stuff. All right, so now we're just doing algebra. So I'm not really doing anything with the stuff in the parentheses, so this is really negative 2x plus 3x plus 11 equals 1. Combine like terms. 3x minus 2x is just x plus 11 equals 1. I'm going to subtract 11 from both sides, and I'm going to get x equals negative 10. Now, I'm almost done. I'm almost done. I still need to know what y is, but I got this equation right here. Y equals positive 3x, but I'm going to plug in negative 10 for x plus 11. Now, I went kind of fast. What I'm doing is I'm saying y equals 3x plus 11, but I'm plugging in x equals negative 10 for x. Does that make sense? I'll give you guys a second to kind of look at it. I know I'm going kind of fast. But to find, so I did all this work and I solved for x, okay? And then I plugged in my x value into the other equation that had a y. Now, when I do the math on that, I get y equals, what's 3 times negative 10? Okay, plus 11, what's that equal? Now, those numbers seem really, really, really high. Mr. Adams is going to double check his teacher book to make sure. Maybe I didn't write something down correctly or something. They're integers, so I'm pretty sure they're right, but I'm just going to double check to make sure. Is there a way I could double check without my fancy teacher book with the answers? Can you guys think of a way? Because you guys don't have the fancy teacher book. How could you double check it? Yeah, so somewhere Mr. Adams made a mistake because it's saying that, oh, you know what I did wrong? What did I do wrong? Yeah, I put a -3 here. I didn't copy it right. See, I put a -3 here, and that's +3, right? Oh man, the whole thing's wrong. Yeah, that happens in the real world sometimes. So that means this would be -3. It's not the end of the world. It's actually pretty easy to fix. So instead of me adding 3 to both sides, I would subtract 3. Okay? So then this becomes a -3, right? So then this becomes a -3x. So then down here, this becomes a -5x. And the only thing that really changes is this very last line. I've got -5x equals -10. Divide both sides by -5, and I get x equals +2. Okay? You guys with me so far? So that's not that hard. And so now there's a couple things that change over here. This is going to be a +2. This is going to be, actually, this is supposed to be a -3, right? So then that's why you should always write in pencil in a math class. That's going to be 2. What's 3 times, or -3 times 2? -6. What's 11 minus 6? 5. See, that's why you write. That's the benefit of writing out all your work. So I got x equals 2, y equals 5. How do I write that? 2, 5. Right? Because that's your x, y. Does that make sense? Yes. Any questions on that one? Now, what I said was that where I was going is that we could graph this on Desmos, and we would find that we had the wrong solution. Okay. And by the way, what do you do if you take a test and something doesn't seem right, and then you realize you made a mistake? Just leave it wrong? No, you gotta go back and fix it. So it's part of life. Even Mr. Adams makes mistakes. That's my third one since 1993. No, it's not. It's probably my third one today, actually. All right. Good job. We're going to stop there.